Hello, good morning, good evening, good afternoon, depends where you are, and welcome to our monthly open hours session. Today we're going to cover the storage technologies that are available in OpenNebula. As usual, we will start with a short presentation on what do we support there, what options do you have when you use OpenNebula. Then we will proceed with questions that were sent beforehand, and then feel free to use chat to ask your questions, and our engineer is going to answer them. Today, I'm with Bruno Rodriguez, the colleague of mine. Bruno, welcome, and let's talk about storage technologies in OpenNebula.
Hello, Alex. Well, here we go. OpenNebula, as every other virtualization technology, it's got it supports different kinds of storage technologies. We're gonna have just we're gonna just make a little introduction about which are the ones that we support, the data store types that we support, the storage drivers, and after that we will just reply some questions and answers. So, well, first of all, we have to think that in OpenNebula, we have three different kinds of data stores. One of them is for images. Every file, in OpenNebula, we make a difference between the images as they are and the system. We have the golden images and the system images. A hypervisor is running on a system image, but the front ends are just deploying the virtual machines from a golden image. So, by the way, as we can see here, we have these two. Mainly these two. After that, we all have also the files data store. The file data store is normally for just files that we want to contextualize, that we want to mount, that we want to have available on the virtual machines in the moment that they are deployed. Mainly, we can think that the image is normally mounted on front end for sure. The front end is going to be the one that actually will have to just make the other just to deploy the virtual machines. And the system data store is going to be mounted only for sure on the hypervisors. If your front end is hypervisor, but actually the system front end, the system data store is only mounted on the hypervisors. So the thing is that the point is that we just have different drivers for the data stores and for accessing what is in the data store. We have normally, regular file systems, POSIX file systems are using the driver DSMAT, and actually using the driver file system, and the Ceph driver is used for Ceph. Actually, we are using RVD on Ceph. We will see this later. And that's it. This type on Ceph, it's going to be RVD on block. With some data stores, as we are using below the data store, below the unit, we are using logical volumes. We use the block, this type. And finally, the transfer manager. It's not, for instance, if we are using a local data store, that means that every hypervisor is storing its own images. We are going to be transferring the golden images to the hypervisor via SSH between each node. That's the local transfer manager. The QCO2, and it's normally for shared data stores. If you have a shared data store just mounted in all of the hypervisors, you don't need to transfer it. You don't need to copy it. And in that case, we are using this one. We have both of them. We have QCO2 and shared. Both of them are just for shared file systems. And QCO2 is a bit better in the way that it just supports some more operations that are used on the file systems, for the file systems, for the images, for the virtual machine images. Then, in case that we are using logical volume, I mean, the point is that we need just to transfer some information, some data. It needs to be transferred via SSH. So we have this transfer manager for file system logical volume management. And finally, Ceph. Ceph is kind of a different thing. Ceph works on its own way. And transferring, it's not I mean, it's a bit different. The way the Ceph works, it's a bit different. We can just explain this on the forum. I mean, you can look for it on the documentation. We recommend you to check the documentation for this. So, well, here we have mainly the system data stores drivers that we have on I mean, the limitations. I mean, the features and the limitations that each one of them have. So, for instance, for local file systems, as you can see, we don't support fault tolerance. Point is that if one of the hypervisors fail, you need to transfer all of the virtual machine running to another one. So unless, I mean, when we mean a failure of a hypervisor, it means that, for instance, the libraries, libvirt, for instance, just falls down, or the networking falls down. So you have no way just to transfer it. So it's not fault tolerant. With NFS, everything is supported. Well, we have to just, I would like just to make a small difference between disk snapshots and virtual machine snapshots. Virtual machine snapshots are keeping as well the memory. So actually you are going back to all of the state of the virtual machine. A disk snapshot is only the snapshot for the block device. In this case, with Ceph and Sun, we rely on libvirt. And libvirt it's not easy just to make a virtual machine snapshot, everything just with the memory. With Ceph and, well, we call it Sun. ESCAS is just a way of Sun. We can consider that it's a SCSI presentation of a LAN over the network. So VM snapshots are not supported in this Datastore with these Datastore drivers. So let's gonna go for the simplest possible deployment, the simplest way of having an OpenNebula deployment with local storage each. So here, as we said before, the front end gets the golden image from the local Datastore for the image Datastore. It's local. We are supposing that everything is local here, and it just transfers with, I mean, the transfer manager is called local, but actually it works in a secure way with SSH. And it transfers securely the image, the golden image, to every host. The host keeps that image on the local data store. Actually, it doesn't keep it keeps just one copy of the image for them. And after that, I mean, it uses Go. We can just clarify this later. But the point is that all of the system data store is local to every host, and is just mounted on the same place on every host. For virtual machine migration, in this case, you have to copy, as we said before, all of the file from one of the hosts to the other one. We're going to call hosts, nodes, or hypervisors indistinctly. So the point is that you need to copy this file from one hypervisor to another. The thing is that it's not, it's live, but it's not totally live. If the file is small enough, you will see just that the virtual machine just pauses. And the virtual migration, I mean, it's not totally live. It's not live in the way that you're going to see that it's stopping for some time. But that the immersion time relies on the capacity and the virtual machine load. You're also, I mean, whenever you are migrating a virtual machine, you're also migrating the memory of that virtual machine. So it may take more time or less, depending on the speed of your network. That's something that happens with all of the data stores, with all of the drivers, by the way. But here we also have to transfer the disk of every virtual machine, so that takes more time. This is totally, absolutely not recommended for high availability. In any case, on the front ends, neither on the front ends nor on the hypervisors or for VMs. But it's a simple deployment, and if everything is stable enough, it would be just a good way just to test OpenNebula. With NAS, whenever we are talking about an NFS shared, we normally, whenever we talk about NAS, we talk about NFS, and distinctly between NAS and NFS. What we can see here is that we can have more than one front end, then we can have, so we can have a high availability. And the image data store, this is one of the ways we can also just keep only the image data store on the front ends, but this will be the most efficient way. So the image data store is available on the front ends, and the host can copy the image directly from the shared image data store. So this is a good thing. Mainly what we recommend as well, I mean, for when we are talking about infrastructure, what we recommend is to have a separated network, a separated NIC, I mean, virtual infrastructure for what it's NFS. I mean, just having your own NICs for NFS with an a good MTU, with just good equipment for the storage, because the storage is going to be just one of the bottlenecks of the installation. And normally, I mean, before OpenNebula 7.0, you had to mount manually. I mean, the NFS share for the system data store had to be mounted manually on every host. With OpenNebula 7.01, it's not 7.0, I think it's 7.01, we already have an auto-mounting feature for the system data store being mounted on every host as far as it's needed, as far as it's created. As we said, this driver, this infrastructure just allows us to have a live migration of virtual machines. We can have high availability on the front ends. That means that if one of the front ends fails, the images are on the other one, period. It's okay. And that's it. I mean, we have a virtual machine high availability, but still OpenNebula just needs to have a hook for that to be applied. There are examples on the documentation for that, but it's just creating a hook. We can just talk about this in the forum if it's necessary. And this is the simplest high availability configuration that you can find, because NFS is just a well-known protocol, a well-supported protocol. It's been with us for quite a long time. And it's quite efficient as well. With Sun, whenever we are talking about Sun Data Store, we are understanding that here we have presented, I mean, I'm talking about Sun, but ISCSI wouldn't be that different from this one. We are just having LUNs that are being grouped in, well, they are physical volumes, and they are going to be just in a volume group. Whenever we have a Sun Data Store, what we have to think is that for the front ends, we still need a file system there. So actually, you will need the image data store. In this case, over this driver, will have a file system. Anyway, it will be accessed only by one of the front ends. So we will have we won't have problems about concurrency. I mean, only one of the front ends is going to access to this file system at any moment. About the hosts, it happens the same. I mean, we have all of these physical volumes on a volume group. Every virtual machine will be created on every virtual machine disk, by the way, will be created as a logical volume. And this is something, I mean, we have this thin logical volume driver that it's kind of new, but we will talk about that in a second. So the point is that every disk on every virtual machine will be created by the host and will be just created on this as a logical volume inside of this volume group that is the system volume group here. Well, as we said before, this requires a VM install on the hosts and disable the meta daemon for this thing about the concurrency and the access to the physical volumes. Well, actually to the logical volumes, by the way. And eventually what we recommend is to use a thin logical volume driver, the thin logical volume. I mean, thin LV, what it does is just not occupying all of the size of the disk, but only the size that it's really used on every disk. The migration, the perks about, I mean, the good things about the migration is that it's the same as with NAS. It's the same as with NFS. just moving one virtual machine from one of the hosts to another one would mean just only transferring the memory, because on the other host you will have the disks that the virtual machine will have the same disks present on every single of the hosts that you have there. And finally, Ceph. With Ceph, we are using RBD behind Ceph. It's here we are not using. I mean, in this picture, we are not having a hyperconverge example. I mean, we are not having a hyperconverge installation, but you can think. I mean, on hyperconverge installation, the difference will be that the Ceph cluster, all of the nodes that are currently running in the Ceph cluster will also be just hypervisors for OpenNebula. So well. Here, the point is that the front ends and the hypervisors need to connect to the monitors of the Ceph cluster, just to create there the volumes as RBD. I mean, they will create just RBD volumes, and the RBD volumes would be will be used as disks for every. I mean, the disk for every virtual machine will be there. The good thing, well, it uses a totally different kind of driver. I mean, RBDs are mounted directly, and well, here we say, I mean, you have redundancy as well. I mean, it's not like you have redundancy. Well, you have all of the perks that the Ceph file systems have. You have all of the, I mean, well, that Ceph has. I mean, you have the number of replicas that you need. You can even just you have all of these data maps. I mean, you can just, well, you can use the cluster. The Ceph cluster can just be taken in the West way, as you know. And well, this is very recommended. Actually, in this one, we also recommend to have an isolated network for all of the Ceph cluster as usual. I mean, Ceph is really, it relies really a lot on, well, Ceph on the hardware side, we can think that it relies on commodity hardware, but it relies on quite a lot of commodity hardware. Just always think about the Ceph clusters have to be thought to expand a lot horizontally, but a lot. I mean, think always that it's better to have 4 servers than 2. With Ceph, it's always just going like, it's better to think in a lot of commodity software than on a small amount of them. And also, it's recommended to have an isolated network for it. And also, there are some network restraints and network complaints. I mean, it's kind of, I mean, Ceph is a wall on itself. And that's why I say that Ceph cluster can be a bit difficult to manage. For simple installations, it can be perfect, but for some things, it can be just kind of complicated. So these are the 4 main drivers that we have. And there are some other data stores, some other kind of drivers that we have for data stores. There is the row device mapping. This is in case that you need one of the, I mean, in case that you need to access directly to a LAN or a drive, libvirt, which is OpenNebula, just relies on libvirt. Libvirt just supports it. OpenNebula, we can just use it. With iSCSI, it's similar, not totally identical to the previous one, but it's actually just finding a device on an iSCSI, and after that, libvirt can just mount it and use it as a disk on a virtual machine. And finally, I mean, we are working on a NetApp SAN Datastore on a NetApp native driver, which currently it's only available in Enterprise Edition. But I recommend you just to get into the form, or actually just contact your support, to your sales department, just in case that you want to have more information about the NetApp SAN Datastore. You can also check the documentation, by the way. And well, these are some questions that we got before the webinar was going to start. I mean, the thing is that one of them is just how do NFS mounts automatically on the hosts. When you define the data store, you can set the NFS server, the place where, I mean, the path on the server where it is, and well, the default options, I mean, the options that you want to use for that NFS mount. I mean, for some people, it's going to be, I mean, you know, tuning the receive size, the writing size, read size, write size, the timeouts, interrupt, all of this. All of these options can be just set on the moment of the creation. Well, actually, they can be changed, but the best thing is just to define them on the moment of the creation of the data store, of the NFS data store. And well, this was kind of a tricky thing. If we decided to use a distributed file system, what would be the best way to handle or configure it? You can think of, a distributed file system, you can think of it like if it was an NFS file system. So whatever it's written on one of the hypervisors, will be just be seen by the other one. So here you should use a transfer manager, here transfer manager, and it will be you will need to use a transfer manager, and everything just to use the file access, because it will be just a POSIX file system. That would be one of the ways just to use. I remember Gluster, but this kind of file systems that actually are distributed, but they are not. Gluster, MooseFS, LizardFS. I think that BFS is the same. These ones should be. You should think of them as shared file system with a transfer manager shell, but it's SSH. Sorry. And with a file system block access. So Alex, I saw you here.
Yeah, hi there. So thanks for answering those two questions that we had. And please note, when you are signing up for the next office hours, make sure if you have any questions to send them beforehand, so we can actually answer them live. If you, for example, don't want to use chat, or if you already have some kind of a question, then feel free to send them beforehand. And also, please use the chat if to ask your questions about the storage types, data store, or anything around that topic. We would be very happy to answer. And we have one. So which data store option we should use if the performance is the main concern? So Bruno, what do you think? What could we suggest if the main concern would be the performance of I assume, virtual machine?
Okay, we are talking about performance. We don't mind about high availability. In that case, local storage is always, NVMe. A local NVMe is probably the fastest. Local NVMe drives are the fastest way to access to your virtual machine disks. If you need this kind of high availability, at least for the front ends, then you can use. Normally the image data stores are not that accessed as much as the system data stores. So in that case, if you want to have some kind of high availability, at least for the front ends, I would check the image data store to be something different. But anyway, the local data stores, an NVMe, nothing right now, for what I know, nothing beats an NVMe drive, a local NVMe drive, when you need to access to some disk. So if performance is the main concern, and high availability and reliability is not that important, local storage is the fastest for everything. If we have just to sacrifice a bit of the performance and we just want to have something more high available, if we want to have more high availability, now I would here I would be between NFS and Ceph. Ceph can be can perform really well, but you need how to manage it. If you have all of the knowledge about Ceph, or you have no problems about just to start learning about it, Ceph is also a very good option.
So we can say, like, to kind of summarize, that local data store to hypervisors would be the go-to if we're speaking of performance. But then if we need to add the reliability and that kind of things, then we should consider the shared storage, though.
That's it. If we are talking about favorite channel, Ilya, I don't know if you are asking what would be used. I mean, can you elaborate a bit more the question, please? Because if what you want to use is favorite channel, what we are using is the Sun driver. Sorry, so yes, the Sun driver. By the way, the storage area network. I mean, all of the LANs that you want to add to a single data store have to be just in a volume group, and that volume group is the one that will be used for that data store. As we said, in the best for Sun storage. Yes, I mean, fiber channel is. I mean, the Sun storage, the Sun driver that we have is for fiber channel. But anyway, just think that currently, okay, I mean, here also comes the cost factor. We know that fiber channel is really reliable. It's really good, by the way. But we also know that fiber channel's hardware is kind of more expensive than actually just having a bunch of network cards and using ESCASI. So the point is that the driver will be the same, but ESCASI with I mean, right now I'm not gonna say 100 gigabit Ethernet cards, but because also the switches for these ones are expensive. But just with some, I mean, you can also, I mean, the point is that you can bond some network interfaces just to have an ESCASI access. So just think that fiber channel is okay, but also the hardware for fiber channel. I don't know right now. I'm not aware of the current prices of fiber channel storage, if they are cheaper than regular gigabit Ethernet things. But for what I understand is maybe, I mean, it may be good, but also it's more difficult to evolve. I mean, it's more difficult just to operate with the fiber channel in a way, and also you have to configure the fiber channel switches. It's a different thing. Everything anyway, of course, fiber channel. Everybody just likes to have LANs and presenting the LANs there. I mean HVAs and presenting the LANs there, but in my opinion, I think that ESCASI is also a good option, and it's probably gonna be cheaper in hardware. I mean, for hardware, it's gonna be cheaper, and the performance, it's not gonna be maybe as performant as fiber channel, but it can be almost on par.
And we have another one question about the front end HA. Can we achieve the front end high availability without using a distributed file system? And what about the virtual machine high availability? Can this one be achieved without a distributed file system?
Well, about high availability without shared storage, I'm afraid it's impossible, because the disk has to be transferred. If some of the nodes fail, I mean, if let's gonna suppose that the main library that OpenNebula is based on, I mean, if libvirt fails on one of the hosts, you don't have a way just to transfer the image. So I mean, all the way, it's complicated. I mean, let's gonna say that high availability for VMs, it's almost impossible. Let's gonna say. And about front-end HA, as far as you have I mean, we are talking about mainly the front-end. The main thing that needs is the image data stores. So as far as you replicate the content of the image data store on all of the three front ends, everything is going to be okay. So for instance, I mean, one of the things that I'm thinking about is whenever you create an image on a front end, what you can do is just replicate them. It can be done with, for instance, with hooks, or whatever you add that. I mean, creating an image, you can have a hook, and after that, just copy to all of the front ends on the HA. Or else you can have a synchronizing. I mean, you can synchronize the image data store on all three of them. For instance, I don't know. I mean, I'm thinking about this little daemon. It's called lsyncd. It's just running on Lua, and it's a simple thing that actually works with events. Whenever there is an event, it just copies. I mean, it makes an lsync of the necessary network file on this one. I mean, it's a very simple daemon. It's just one of the ways. As far as you have the image data store, the image data stores, because there may be more than one replicated in all of the front ends. Front end HA should be okay, should be working correctly. I don't know if that was clear, if there's any question about it.
Well, I don't see any follow-up questions on that. However, there is, well, coming from the same person, can you combine different storage options on a single OpenNebula environment?
Of course.
So you basically can use a
yes,
different
you can have
storages.
For instance, you can have local. I mean, for instance, you can run virtual machines on what we were talking about before. So if you want performance, but you don't mind about high availability on the VMs, you can have just a local storage, a local system data store on the front ends. That one can be running on, that's it, an NVMe or something like that. And then you can have you can separate everything on clusters. You can make groups of resources on clusters. So you can have one cluster that uses NFS, and that one has high availability for the VMs. And you can have another cluster that is using only the local data store, and that one is okay for virtual machines that actually they are not a problem if they get, they don't need high availability.
Cool. Thank you so much. So once again, I would invite others to also participate in the comment section. So please drop your questions in the chat. Outside of these office hours sessions, should you need to have any assistance, obviously you can visit our forum. So there's like a community of the OpenNebulars that are actively participating in the conversations, and there is a huge opportunity that your question already was answered by someone in the community. So feel free to check out the forum, as well as join our other events. We are running a lot of other awesome events on different topics, whether it might be another office hours sessions, maybe some training webinars, or maybe the feature, so where we speak about the new feature that we are presenting. Or, for example, yesterday we had discussed the new stuff that we have in the version 7.01. Okay, so I don't see any questions coming from our attendees. So I would like to say then, thanks for attending. It was a pleasure. Thanks for your questions. And don't forget to follow us and attend the other office hours on the more interesting topics and more challenging ones. Oh no, sorry, we do have another question. Have seen some problems in the web UI. Doesn't update storage when I try to mount new local storage directory.
Okay. When we are talking about, it's local storage. If it's a system data store, you have to think that if it's local to every hypervisor. So every hypervisor is the one which knows what's the amount of storage of free storage that you got. So then you can see the storage sum. It's managed by the own hypervisor, and also managed by the scheduler. The scheduler will find which one of the hosts, which one of the hypervisors has enough space for a virtual machine on that one. About if it's about local storage directory, that's it. When we are talking about system data stores, I don't think I don't know right now if it's fixed in 701, because the point about the local storage is that it's not the sum of all of these storages, but actually it has to be just checked on every hypervisor. Yes, that's it. For the system, that's the point about for the system hype. I mean, in this case, it's the scheduler, the one that checks the amount of. I mean, it's not you will not be able just to check it directly on the hypervisor, but the scheduler just keeps track of it. It would be nice just to have that. I mean, that's one of the things that we should just check for as a feature, just to see all of the sum of all of the local system data stores on the hypervisors. But yes, currently I mean, as the scheduler is the one that actually is taking care of this one, we don't monitor it correctly on the front end.
Well, I think it might be actually challenging here if we bring up this to discussion, because each hypervisor has its own storage and it may have different size. So you may think that you have, I know, 100 gigabytes of free space, but actually it's just a sum of 20, 20, 20, 20, 20. So it has its pros and cons. Yeah, so if pretty much the local system data store is shown as 0, because we kind of cannot determine which one you would like to see, and then if we combine it, then it may be misleading. So it's
That's
my
totally
take.
right.
So it's just my take. I wouldn't want to have a sum under the data stores of the type system local, because then it may play a trick with me. I would think that I have hundreds of gigs available, but it's just a small portions scattered across all of the hypervisors.
That's it, and that's why the scheduler is the one which takes care of that one. I mean, the scheduler is the one. I mean, let's gonna suppose, as Alex said, you have one of the nodes has 100 gigabytes, and the other ones have 10 gigabytes on that system data store. I mean, if you say 150, you think that okay, I can just put a virtual machine of 120 gigabytes here, but you can't.
Good. Okay. Any other questions? Feel free to ask them in the comment section. Well, I assume that we don't have any more questions. So we can say then thanks for attending. Thanks for your questions and being active in the comment section. And see you next time.
Thank you very much.